Okay guys, so welcome back again for the another series. So today we'll be going to write exercise stream bus. We'll be making IP, which will be taking a data, which will be taking the data from the another guy, and which will be processing to which will be processing to the another guy, right? We'll be developing the IP which will be streaming the data, which will take the data from the one guy and which will invert all the data bytes, all the data bytes, all the data bytes and process to the another guy, another slip. Okay, so just I'm going to take you through. Okay, so guys, today we'll be talking about XI4 stream interface. As you know that axi4 stream interface is the point-to-point interface. There is no concept of the address, right? As in the XI Lite and XI4 memory mapped interface. There is a concept of address, but in the XI4 stream interface, there is no concept of address, right? And XI4 stream interface it has a high throughput. But the drawback is it is not memory mapped. It cannot directly talk to the Zinc. We cannot interface with the Zinc processor. We cannot directly communicate, right? So we need some kind of bridge. We can use the DMA and XI stream to memory mapped controller we can use from the Xilinx, right guys? So show the another. So I'm going to show the easy module. So this module XI Breeze XI4 stream interface will be developing this IP today. Okay guys, so this guy will be taking the data from the any masters. This master will be giving the data to our this IP, and this will be processing that data to XI and slave, which will be talking in the XI stream interface. Okay, so we are going to write live code in the VSTL. Okay, so guys, I'm just taking you through the VSTL code. Okay, so let me try data processing. Let me write like this. Data processing. Okay. Let me give some another name. Okay. To find data processing, we have just given the name of our entity. Okay. Okay. Just let me. Okay. Okay. Now we are going to follow the Xilinx style of coding. Okay. So I'm just going to enable this. Okay. So now the X system is reset actively reset. Okay. So I'm going to give xi clock as input. Logic reset and okay guys, so so our slave input slave ports. I'm going to define it ports and the master. Okay, the slave ports there will be taking it will be taking the data with the file signal. So we are writing a stream. So we're just going to follow the Xilinx coding style. Okay guys, so XIS file it. Okay, logic axis data. And logic vector. So we are going to make it as parameterized. And another is ready signal. It will be logic. Okay, so here I'm going to make it as generic data teacher holding 42 pages of data. Okay. Now there will be some output tools and access wallet. Access data. Logic vector with -1 down to 0. And another photo with the M axis valid. M axis ready signal. Steady logic. Okay, so these will be the ports of our IP simple application. Guys, so very as an engineer name design. We could say data processing. And we are making the data as inverter. Okay, all the 32 bits of the data will be inverting, and this data will be processed. Okay, just let's take it as data processing. Okay, guys, so okay, now we are going to store the data. M axis when process. So we'll be coding one by one. Okay, so this valid signal slave will be valid. Slave valid signal will be coming from another guy, so we don't need to code this. Okay, we need to first, so we are going for the data. This we are going to store process yes block. If rising edge of clock, axis clock, and if rising edge of the clock, then we're going to invert the data bits. Okay, guys, so what we're going to do here is for I in 0 to data width divided by 8 loop, and we'll be storing the data. I am access data. I'm access data, and we'll be inputting the data, okay, into it. Every times will be into it plus 7 down to I into it. Okay, so down to I into it less than equal to slave axis data I into it plus 7 into it. So here we are going to say end. So here will be the end loop, end of if, says, and okay, here is another error. Now error is gone. So here what we are doing is we are taking the data from the slave interface and we are making it we are importing. For now, as of now, we are just processing by importing. Okay, 255. If we okay, if we okay, just we need to convert it as unsigned. Signed. Okay. Still unsigned is not declared. We need to declare first. Use IT polyester signed. Library, you need to include this library. Still, you are getting an error, so in case we need to include unsigned. Still, if you are getting the errors. Okay. So we are getting error over here. What's the it's not declared. Still logic. What we do is to unsigned. We do this. And getting still error unsigned. 255 minus it as vector. Alright, so actually we don't need to put this. Okay, so this access data. Oh guys, we were doing the mistake. We had not include that library because we need to include that library to use that. Okay guys, so if we comment it out, then it will not be understanding what we are doing, right? So for this, we need to include this st use itinerary numeric std.all. This on the scientist declare in the numeric std or all packages. Okay, guys, in this library it has declared. Okay, so we are done. Every byte of the data will be inverting. That means if we if we subtract the data from 255, then we'll get the data inverted data, right? Is 8 bit if we subtract 8 bit of the data from 255, then we'll get inverted data. Okay, so let me show you. Let's do 10 minus, if we are subtracting. Okay, so if there is 255 decimal 255 and we are subtracting, that is, let's suppose 255, then here we get the inverted data as 0. Again, let's subtract 255, that is 111. You can see in the binary minus, let's suppose I'm subtracting that, that is 200. Okay guys, so here you will get the inverted data. So we are basically making the inverting of these data bytes. Okay, so this is the master axis which we are storing the data, and another where master will be valid 1, and if rising of the clock. And also here we have missed one thing: if slave is valid, its axis with the the data is valid, and its axis ready. The slave is ready and the slave is the valid. Then then only will go inside this loop. Okay. Valid X. Okay, slave is valid. This is also 1. Okay, in that case only we'll be expecting the data of distributed logic. Here cannot read out. Yes, we are making a mistake. This will be okay. We cannot include directly, so here we are signal. The valid and the accessory. Okay. In that case, only will be writing the data, and master will be valid. M axis and the master will be valid only when the slave is valid and slave is ready to accept the data. So that means the M axis valid because we're getting the data after one clock cycle. So this will be the actual. Yeah, this is the S axis. This valid and S axis ready. Process. Okay, we're done with this as well. So we're left with so this will come from the slave. So we're left with this S axis already. So basically we are going to store this data. S axis already will be the actual M axis. When the master is ready, then S axis will be the ready to access the data. This wire, and the finally slave will be ready. Slave is ready, that means the master is ready. So we are done with the here. Whenever the slave, let me show you through the presentation. Whenever the xi slave, this module is ready. This module send the ready to the master our base, then only because we have not created any buffer inside this, we are just taking the data from xi master. We are just processing the data to the slave up to one clock cycles, right? We have not the buffer, we have not buffered our data. So that we are just whenever the slave interface slave is ready to access the data, that means MX is ready, right? If this is ready and this will be the ready. That means x-axis ready will be if s-axis will be ready. Our slave is ready to accept the data. It will uh, only one time access ready when the another slave is ready to access the data. Okay, what we wrote on our code. So now let's okay, so this is the slave. We are done with the slave and valid will be coming. Valid will be the when slave gives the valid data and the slave gives the valid data. Okay, and slave is ready to accept the data. Master is ready. Okay. Okay. Now we are going to save it and we are going to create the IP of our design. Okay, we just need to go to the create and package IP. We are going to this and package your current project. I'm not going to create new XI peripheral IP. Okay. And so we are going to package our IP. Let me see IP location. So our IP location is 19.2 project Zygo 800 test. Source one new IP location. So we will be creating using our IP and will be able to edit. Okay guys, so we are in this interface. So will be vendor name. Okay, let's give my just technology.com. Okay. Library user, it will be stored in the user data processing version 1. Okay, where compatibility you can select any family. Let's where to choose as Arctic 7 and the zinc device is okay, zinc 7000. And now we are going to file groups. So inside this, there is no any file. There is simulation file and there is no STK, no driver files because this is the memory mapped interface. Okay, customization parameters. Inside this customization parameter, you can data with 32 bits. So ports, you can choose your ports. We have mentioned that ports. Okay, so here you can we can make input and output port as a group. So we are going to make it as a group by let's keep say memory map here. You need to choose memory map and XIRTL. Okay, we are stream interface we are making, so we are going to choose as XISRTL. Okay, so we are going to give, let's suppose we are x-axis giving the name making slave. Okay, and here we need to go to port mapping. Here's actual, this is the actual signal with Xilinx Pro and this is our signals. Okay, so we are going to map our slave interface. So T data will be going to map with the XI T data port map, and there will be T valid signal, S valid signal, and after T ready signal is going to map with the XI ready signal. Okay, we're done with the mapping. Now you can see here below this axis, we can give an name as access data, as access valid, access ready, and we are going to create the master ports. Map, we are not going to create XIS RDL. We are going to give it as an axis master interface, and here we are going to give T data. We going to map with the master data signal port map. T valid master valid port map. T ready signal is going to map with MAM axis ready. Okay. So we have made these ports. Okay. Now there is a, since we have this is the clock. Okay, so let me. Okay. So for the clock, we need to give this. So we need to provide here associated bus parameter. Associated bus parameter. Okay, still we're not getting any error over here. So there is no address mapping concept. 3 warnings. We're getting 3 warnings. Okay, so what are the warnings? Let us see the reports and the warning. Okay, bus interface we need to give. So to give the bus interface for axis clock associated bus interface parameter is missing. Bus, okay. So we are getting for the clock. This clock is going to use by which interface? Okay, so we need to go to the add bus interface. Okay, parameters. What? How do we assign this interface? Just hold on, guys. Okay, so we were stuck over here, so we need to give clock. We have to go to the parameters, type associated bus interface. And so associated bus interface. Frequency heads. to go below over here and to keep the value. M-axis and x-axis. Click OK, and another parameter we're going to assign as frequency hedge. Frequency. Hertz 1.125. 1, 2, 3, 1, 2, 3. Hertz. Okay, now the error has gone. Okay, guys, so we have provided the default frequencies and in the associated bus parameter, as you can see. The associated bus, because if you provide these M-axis and S-axis, will be using this clock for the place and route, it will be using. And this also we need to provide the frequency in hertz. What will be the default frequency over here? Just click, you need to click it OK, and it will be the problem, the warning will be removed, and in the address there will be no address concept. So as you can see here, your IP will be look like this in the GUI. We have grouped our signal of the M-axis and S-axis, you can see. Okay guys, so we're going to package this IP and you can use this IP. Okay guys, so we're done with the IP. Okay, so now you can use your IP. .2 projects we just created, I guess, the Jaibo. I just made Jaibo where it created the user test inside the internet test. Okay. We made it as data processing. Inside the IP, okay. Okay, let me go here. Here you can see our IP data processing. You can add your IP and you can use this IP, right? Here's the ports we use: S-axis data, S-axis valid, X-axis ready, and M-axis data and validation. Okay, in this way, you can make your IP. And if you go to the settings, if you go to setting and the computer is a little slow. Inside the repository, you can see the path of your IP, right? Right, so your IP path is not a project Jaibo Ethernet source one new project here. My IP is stored. Okay, right, so you can add the path where you have stored your IP. In this way, you can make your IP custom IP and you can add in your design. Okay, thank you so much, guys. And if there is any query, then you can comment and you can reach through me through my email ID of channel or blocks. Okay, thank you so much.